I apologize that I wasn't here. How are you doing with the assignment? Yeah, we've got 20 things now? Yeah. I had an idea that might be kind of fun. Who's K44? Okay, then K45. Okay, so why don't we have a little competition? Let's put K44. Okay, so let's look at what we have so far. So, interesting. I think it's interesting that for both of you, the first thing you wrote was man. That was the example I gave. That's interesting to me. So the first thing is to repeat. I saw, where did I see it? This one is interesting to me. How does that mimic nature? So you said it imitates nature, so I'll ask you, how does a water pump imitate nature?
With the pump can use some very water from river or somewhere to the house and
so your argument is that it imitates nature because it pushes water along, creates something like an artificial river. And you would say there's nothing quite like that in nature. Yeah, it doesn't seem like there's anything quite like it in nature. What is the water pump's nature? Hot, right? It's heat. Evaporate the water, it goes up in the sky, cools off, comes down in the mountains, higher up. So, a mechanical water pump, I think, is something that's not really in nature. But it's not right or wrong. I'm just interested in your idea. Mirror. We both had mirror. Now, what does that mean to take in nature? There are a lot of famous fables from old days of people that lean over to look at the water and see what's outside. Usually something bad happens. Usually something bad happens in those stories. But we all have a mirror today in our house. So maybe we're not very smart. We didn't listen to the story. Building, mattress. Interesting, yeah. So in nature you would say lie on a soft surface. This is interesting. Medicine. I said on Monday, I thought the biggest industry in the world is automobiles. That may be true, maybe not true, but it won't be true forever because what's the new biggest industry in the world? Medicine, right? Especially design, what's so-called designer medicine. So I think this is very accurate to put this under mimic nature. That's the new idea. You take somebody, you measure their DNA. We know what the DNA predicts about the way everybody's body works. So in the old days, if you had a headache, we could all go to the doctor with the same headache, and the doctor would say, take an aspirin. He'd tell everybody the exact same thing, take an aspirin. Not too long from now, 5 years, 10 years, 1 year, 20 years, I don't know when exactly, but sometime pretty soon, we could all go to the doctor with a headache, and everybody gets a different medicine. Because my body is different from your body, is different from your body, and so on. So, that's the idea of trying to mimic nature, is that the new medicine, instead of being one medicine for everybody, it'll be very specific, that it fits your body. It's very natural. Let's see, how many do we have the same? We have to correct her. Cell phone, we both had cell phone. Telescope is interesting. Yeah, very, very, very helpful, very useful. You could say microscope also. Amplifier, radio, camera, remote control, pump, thermos. This reminds me of a joke. You want to hear a joke? It's an engineering joke, which means it's not very good. But, okay, so a professor is in a class like this, and he asked the students, what are the 3 greatest inventions of all time? And one student said, the airplane. And another student said, computer. And another student said, thermos flask. professor said, thermos flask? It doesn't seem like it's so brilliant. Why do you think that's such a great invention? The student said, well, it keeps hot things hot, and it keeps cold things cold. And the teacher said, still, it doesn't seem so brilliant. Why do you say that? And the student said, well, how does it know? You know, which one, whether to keep the hot thing hot or cold. All right, sorry. Washing machine. Does it mimic nature?
Why not? Somehow.
Maybe it does. Maybe this one would go over there. It's not important, but maybe this one that does kind of mimic nature. At least what humans do. Okay, lamp. You both had lamp. That's very helpful. Fridge. Lighter mimicking nature. Fire. Okay, so now we would like to add something to this list. K44. Who's in K44? Okay, why don't you add a couple of things? Do you have something different? Okay. K45. Sure. Yeah. Transportation. We have a plane, but nothing else about transportation. That's another huge change for humans. You know, for most of history, most human beings lived in a very small area. They never went anywhere. Right? Today it's possible to go literally all the way around the world, and lots of people travel a long distance. Another thing that had a huge change in the experience of living as a human being. But the single biggest one was agriculture. So how about some inventions from agriculture?
The pump.
The pump could be, the pump was something big for agriculture. Kind of combine or something. The tractor, right? The tractor can do a lot of work. All kinds of implements, hose, shovels, right? How many of those mimic things in nature? Chemical fertilizer is a huge invention. Chemical pesticide, another huge invention. So what from agriculture mimics nature? Tractor does something like a buffalo, right? I'll keep it. Okay. Was this interesting? Did you have fun thinking about it? Or? Yeah. So let's just back up for a second and remember that the whole idea with engineering is that we're going to create the world that has not been. So I realize at this point, especially if you're K-44, you already got a lot of classes. Maybe you have the idea from these classes that the job of an engineering education is to just teach you certain things. If you can answer the question on the test, you must be a good engineer. Actually, the job of engineering is to think up something new that's important, that people want, that they need, that helps them. Or at least, even if it doesn't help them, they want to buy it. So you can get rich. So that's the job. All of the other courses are to help you prepare to do that job. So you learn dynamics because a lot of engineering inventions have the dynamics in it. Everything in transportation has dynamics. Inside the computer, there's actually a lot of things that have to move around a little bit. Right? So there's dynamics. Air conditioning, dynamics. Agriculture, dynamics. So it's very important that you're learning dynamics right now in K-44, right? 207. You want to learn how to use a computer well, right? That'll be the next class, 230. You have statics already, and there are a lot more classes that will come. But those are all tools. Those are just tools. What is the profession that you're trying to accomplish? What is your goal? Yeah, this stuff and the stuff that's not on here now. How about this for an assignment? What if I asked you to list 10 new inventions that don't exist yet?
That is hard.
You don't have to invent them. You just have to imagine something. What's something you would really like to have? A time machine. A time machine would be great. Yeah, I could have used one many times in my life. You make some mistakes, it would be really nice to be able to go back and try it again. So, time machine, I agree with that one. What else?
Weather machine. Weather machine.
I'm sorry, didn't hear me.
Weather machine.
A weather machine. Yeah, to change the weather. We could turn the heat down outside a little bit today. Yeah. Weather machine would be nice. What else? You know, I'm older than you are, obviously. I still don't think I'm really very old. In my life, it's amazing how things have changed. I could never imagine a cell phone when I was a boy. Certainly couldn't imagine a computer. Impossible. You know, we just barely had a television. And my television where I grew up had 2 channels. And they ended in the evening at about 10 o'clock. During the night, there wasn't anything. In the morning, about 6 o'clock, it came back on. Okay, so when I was a child, no computer, no cell phone, basically no television. I spent all my time outside playing with friends, digging in the dirt, doing that kind of stuff. What do children today do? Yeah, they've got big thumbs, right? They're video games, computers, televisions. So it's a completely different existence in some ways. Completely different to be a human child today than it was when I was a child. And I'm not that old. Right? So what is it going to be like for your children or your grandchildren? That's the thing you need to think about. What are you going to make for your children and your grandchildren? Time travel, yeah. Think your grandchildren can go back to my childhood and find out how boring it really was. Okay, so we had time machine, and we had a weather machine. That sounded like a good idea. What else?
Step machine.
One step.
No, I just take one step to get to Buffalo.
One step machine to get to Buffalo. Yeah. Actually, here's an idea. Here's a good problem from your dynamics class. Go home and make this calculation tonight. Here's a new dynamics question for you from K-44. If you start at any place on the surface, if you could dig a tunnel straight through the earth, right? So gravity pulls towards the center. Right? The gravity is always pulling towards the center. You drop something in this end of the tunnel, the gravity will pull it and make it go faster and faster until it gets to this point here. And then the gravity pulls it and slows it down and goes slower and slower. And it's zero when it gets here. So you leave it at one end, and it comes out at the other end, zero. And you can do that from Hanoi over to New York, where I live. Same idea. And it turns out, if you make the calculation, it takes the same amount of time. About the same amount of time. So go calculate and figure out how long that is. You did this already, you said there. So here's an invention for you. You can invent this. You have to dig a lot of tunnels though.
We cannot do that because it's hot inside her.
It's very hot inside, yeah. There's a few technical problems that we need to work out. The beta version, we have to deal with the heat. It's also based on zero friction. If there's a little bit of friction, then you won't quite make it back up the other side. Just like a bungee. You drop somebody on a bungee cord. They fall, they come bouncing back up, but they don't come back up here. They come back up to here. So it's the same idea. If there's no friction, they can come all the way back up. But there is friction. Okay? So there's an idea. There's a teleport machine to get someplace fast. You said one step. This could be it. One step into the hole. Hold your gun. Okay, what else? What else would your children like to have? Yeah, have us memorize everything. This idea has been around for a while, but nobody's figured it quite out yet. But the idea is take a little chip, 10 gigabytes, 100 gigabytes, whatever, it doesn't matter, 3 terabytes, right? When the baby is born, you implant it, say, back here somewhere, maybe in the jaw, a couple of wires into the brain, and the baby knows everything there is. All of the libraries in the entire world, all of the books on that chip, wired directly into the baby's brain. They never go to school, they don't need it. You want to know when Christopher Columbus was born, just ask the baby. You want to know anything at all about anybody, any piece of history? Physics, string theory? Oh yes, I know all about string theory. The baby's on his back. He can't walk yet, but he knows string theory. Yeah, actually, here's an idea that's been proposed. The human brain is made up of neurons. And we can simulate the performance of a single neuron already with a computer chip. A neuron does a very specific electronic thing. And we can mimic that already in the lab. So inside of our brain, there are billions of neurons, and they're all connected in certain ways. But in theory, we could go into a laboratory and create the same chips and connect them in all the same ways. So we have electronics, an identical thing to the human brain in the lab. Now, you could record your life, and we could go load it up into the computer lab, and that computer would know everything that you know. It would have the same memories, the same experience. All right? It would be electronically identical to your brain. Now, here's your one-step travel. Okay, let's say you decide you really want to go to New York. So you go into the lab, you download your brain into that computer. Then somebody hits the send button, and your brain goes through the internet. And over in New York somewhere is a robot with the same electronic brain. And we load your brain into the robot, and now you're in New York. You can do whatever you want. How about that? Yeah, it's amazing. Maybe you have 2 girlfriends. It's a problem because you have to see both of them at the same time. How are you going to do it? You download your brain into the robot goes with one of them, you go with the other one. You think your children want to do this?
Yeah.
They can go anywhere. How about space travel? Your children want to do space travel? Yeah, I think that would be a big one. go into outer space. And if you combine the space travel with the robot idea, it could be completely safe. Download your brain, send it up into the robot. The robot walks around Mars for a while. He doesn't need oxygen, he doesn't need water, he doesn't need food. After he has enough fun on Mars, he sends your brain back, and you just put your brain back in, and then you remember, oh yeah, I was on Mars. Yeah, I remember that. It was a lot of fun. The beer wasn't so good, but everything else is fun. What else? We're all going to get rich, right? We've got to keep thinking of these ideas. We can read what people think. Okay, that's a good idea. Again, there's electronics flying around inside our heads. Right? That's when we're thinking. It's an electronic signal. We should be able to build some kind of detector that could detect those signals and interpret them. Know what somebody thinks, you could know what they know. If somebody has in their memory something, you could know it by reading that signal. You could know all of their memories could be your memories. I remember when you were a baby. New kind of energy. Right? Something clean. Some nice clean energy, unlimited. Food maker? Yeah, some kind of food maker. Maybe we could just get rid of food. Yeah. Just click a button and have a hamburger.
Without looking.
Yeah.
Lay there.
Yeah. We could download our brains into that computer in the lab over there, and then hit the right button, and it sends a signal in our brain that makes us think we just ate the most delicious hamburger in the world. Oh man, is that good? And then load your brain back into your body and go home. Right? That could be the new restaurant. Actually, this is a separate story, but I think this is really interesting. I want to hear your opinion about this. So I have a friend in France who owns a factory that produces smells and tastes. Okay? The biggest customer is dairy farmers, because it turns out that there's a plant that cows can eat, and if they eat this plant, they have a lot more milk. But the cows don't like it, so they naturally won't eat it. So they created some flavor, something like chocolate or something for a cow. And if you put this flavor on the plant, then the cow wants to eat the plant, and then they produce a lot more milk. Well, that's a lot of money. You know, producing more milk is worth a lot of money. So this is a very successful company, and it made it rich. But in the meantime, they're interested in everything that humans smell, everything we taste. How does this work? So it turns out there's a restaurant in Paris, and in the restaurant it's completely black, no light. When you go in, they explain to you what you can order to eat, and you tell them what you want, and they bring you the food, and you can never see them. Okay, you can only taste them. The idea is that it will really focus your mind on the flavor of the food. Okay? Sounds very interesting. Here's what's really interesting. Most people, if they can't see their food, they can't tell you what it is. Like, they don't really taste it. You have a conditioning from your whole life. You eat a certain food and you feel a certain way. So you have this idea that you know what it tastes like. But actually, for most people, if you can't see it, you don't really know what it is. Now I think that's very interesting. Try that experiment at home sometime. Put a blindfold on, have somebody give you something to eat, see if you can tell what it is. Somebody you trust. Have somebody you trust to give you something to eat. Okay. What else? What else would you like to talk about regarding this whole idea that we're going to create a new world? That's what we're doing as engineers. Which one? I still don't think so. Invisible coat. Yeah. Yes. Yeah, invisible. I personally believe that invisibility will be possible. Yeah. Because, well, light is one wavelength in the electromagnetic spectrum. And humans have already figured out how to hide certain other wavelengths. So the time will come, I think, when they'll figure out how to hide plane also. Right? It could be simple like this. Suppose I'm wearing a coat that has a camera on the back, or maybe several cameras. So it takes a picture of everything behind me, and it projects in front of me an image of what's behind me. So that if you're looking at me, all you see is what the camera on my back sees behind me. So you see exactly what's behind me, you don't see me. I mean, that's possible, right? So. Okay, visible code.
We can make food from air and water.
Yeah, make food from air and water.
So
If we could do that, we would be as advanced as a plant. Yeah, plants already figured out how to do that. 3 billion years or so ago. We still haven't quite figured it out. Yeah, what else? A car that runs by water. Yeah. This is another thing that we sort of know how to do already. A hydrogen fuel cell. Yeah, a hydrogen fuel cell works like that. The only part of that we haven't figured out is how to keep reloading the hydrogen. Okay, what else? Anything else, or is that enough of this? Well, I hope it's interesting to you. I hope it's exciting. And I'm looking forward to the new world that you're going to make. I hope I'm still around to enjoy some of it. Yes?
I saw last time the product that we use when to when we think we practice now in cells. But how can we replace and what can we use cells now to have lower button?
Yeah, so like some of the basic biological functions or something? Yeah, I don't know. You're asking the wrong man. I don't know very much about biology. Okay. You can put my brain in the computer lab over there. Yeah. That's good. Okay. All right, so why don't we move on with our discussion? So what exactly is an engineer? The word engineer supposedly first appeared in the 11th century. So 11th century, those are the years that begin with what two numbers? What century is this one called? In the West, anyway. This is called 21st century, right? But it begins with 20. So 11th century begins with 10. So in other words, about 1,000 years ago. So the word engineer is about 1,000 years old, and it's from Latin. I don't know the exact Latin word, I don't think it's that important. But what the word means is one who is ingenious. What is ingenious? Ingenious is somebody who's really creative, really clever, right? If you play a game like chess against somebody, you just can't beat them no matter what. They always find some way around it. They always beat you. That's ingenious, right? They always come up with some solution to the problem. So that's where the word engineer comes from. The word engineer comes from somebody who's like that. Somebody who always figures out some way to do it, some way to get around it. some way to accomplish, some way to win. Okay, it's very interesting. Now, for many centuries, engineers came from an apprenticeship system. What is an apprenticeship system? It's still true today in a lot of other fields that people learn apprenticeship. Apprenticeship is when you go and you study with somebody who's an expert in that field and you work for them. You're their assistant for many years until finally you're good enough that you can go and do it by yourself. So maybe somebody who makes shoes or makes a brick wall, even car mechanic might be just an apprentice. Right? Lots of car mechanics don't really go to formal school. They go and they start working in the garage with another mechanic. At first they do very simple things. Slowly they learn more and more, and finally they're pretty good. Right? They can become their own mechanic. So that's the apprenticeship system. That's when engineers were. They were just like any other apprentice. Many of them, even in the very old days, were artists, or sculptors, or especially architects. So they had these great ideas, like we have today. They knew they wanted to create something, but it was difficult to do it. It was physically difficult to do it. It was hard to figure out how is this possible to make this thing. I can draw this great building, temple, but how am I going to build it? How am I going to get the rocks all in the right place, get it to stand up, and so forth? Most of engineering was done by trial and error. Are you familiar with this phrase, trial and error? Yeah. Try it and see if it works. Right? You have no way really of predicting in advance. Just a guess. There were some great successes. The ancient world was full of some unbelievable things. And then there were a whole lot of failures that we don't know about. So the beginning of modern engineering is often attributed to the Renaissance period in Europe. This idea was revolutionary. It seems obvious to us now, but it was really something very unusual. The idea that you could predict the future based on what you knew about what had happened in the past. That sounds too obvious, and yet it was something really unusual in those days. And especially when it came to things like building. Like, I might actually have a way of calculating whether or not this building is going to stand up before I build it. Before then, nobody thought that was possible. It was trial and error. And usually in trial and error, one of two things happens. Right? Can you guess what they are? One is pretty obvious. What's one thing that happens a lot with trial and error? It doesn't work. That happens a lot. Okay, what's the other thing that happens with trial and error? You have something that works, but it's much more than what it needed to be to work. Right? In other words, let's say I'm trying to build a building and I want to make sure it stands up. Usually, it's going to fall down if I don't know what I'm doing. But one way that I can make sure that it stands up is to make it so ridiculously huge and massive that it can't fall down anyway. But then I've wasted a lot of energy and a lot of material, a lot of resource, because I made it much bigger than it needs to be. I'm just not good at knowing when is enough. That's what really separates this division. Because now with the scientific method, people started to do experiments, they could measure the strength of materials, they started to figure out laws of nature that seemed to be predictable and repeatable, and now they could start to design something on paper without building it. And they have a pretty good idea that it's going to work or not work. Do you know this name, for instance? Have you ever heard of that guy? Yeah. When did he write his famous book? What year? Principia, it's called. That's Latin. It means principles. He discovered some laws of nature that are just unbelievably important to us even today, including the one you're studying in 207, or 208, if you're in 844. When did he do this?
15th century.
1629. Okay. So a long time ago. But at that time, everybody understood the idea of gravity. They didn't know what to call it. They didn't know how it existed in nature exactly. But we all know that you can't jump up to the moon. Right? Everything's trying to fall down all the time. The Earth is somehow sucking us in. We know that. But it was trial and error to figure out just how hard is that trying to pull us down. How strong does something need to be to withstand that? If I want to throw a rock from here across the field, how high does it have to go in order to fall on the other side? All of those things, we had no idea. Trial and error. And he discovered the physical law that actually describes exactly what happens. Then he did something that in some ways is even more remarkable. What was that? When he discovered this physical law, it turned out to be a differential equation. What kind of mathematics solves a differential equation? Calculus. We call it calculus today. So now we all study calculus as if calculus was something that everybody knew forever. Right? Calculus seems like some really old knowledge that everybody has known since the beginning of time. It's not true. Isaac Newton figured out what these laws of nature were, and the math to solve the law didn't exist. He could write down the equation, but nobody in the world knew how to do the math to solve it. So he invented the math that solved it. Today we call that calculus. Okay, another big name in these days was Leonardo da Vinci. He's very famous for having drawn lots of nice diagrams of mechanisms and machines that he could build later, or said he could build later. Okay, can we be a little more quiet out of consideration for neighbors? Okay, and also there, please, a little more quiet. So Leonardo da Vinci was one of these guys that could use the scientific method and draw diagrams of machines to build in the future with a pretty good chance that they would work because he used the scientific method. Okay? Then came the Industrial Revolution. What was the big invention that started the Industrial Revolution?
Steam engine.
The steam engine, yes. Brilliant. Brilliant. How smart was the first person that dreamed up the idea of the steam engine? Scottish. So that was brilliant. Again, changed the world. Now, more and more machines were produced. It was necessary to have people that knew how to run the machines. And this really began the period when it changed from a system of mostly apprenticeships. It started to change to a system with some formal education. And this reached a peak in France with the so-called Grandes Écoles. And that's a system of French engineering universities, and it's still the system in France today. And this began under Napoleon. And it was really the first large-scale formal education for engineering, including a system of diplomas. Okay, why did I bother going through this history? Because I want you to continue to think critically, think open-mindedly about what it is that you're doing in this classroom today, in the classroom tomorrow morning, tomorrow afternoon, whenever. Right? What is it? What tradition are you following into? It's a tradition that began with a bunch of people that didn't really know anything about science, but they had big ideas and big dreams, and every once in a while they pulled it off. They built something like the Colosseum or a giant temple complex or something. They did it successfully sometimes, but most of the time they weren't very successful. Slowly and surely, humans started to accumulate more and more science knowledge. They began to realize they could predict the world. Right? Then, all of a sudden, we invented some machines that started the Industrial Revolution. We learned how to use fossil fuel. Right? We learned how to use energy. And it's been an explosion in the last roughly 200 or 300 years of technology. Just incredible change of technology. Which led to a formal education system in engineering and diplomas. So you're in a program now to get a bachelor's degree, right, in mechanical engineering. A bachelor's degree in mechanical engineering. After 1 million years of human history, the first bachelor's degree in mechanical engineering was only about maybe 200 years ago. That's pretty amazing. Okay? That's pretty amazing, I think. So, you should be a very, very careful consumer. People that are delivering a mechanical engineering degree, like me, are working from a relatively short history, and the technology behind it changes all the time. So what do we teach? What you're going to learn in this program in the next 4 years is not the same thing that I learned a little while ago, maybe a little longer ago, when I went through the program in 4 years. It's much different. I already told you, when I was a kid, we didn't even have computers. When I took my first engineering calculations course, I took it on a slide rule. You know what a slide rule is? Never seen one? Oh, maybe I can find one somewhere. Who's seen a slide rule? And what's the principle behind a slide rule, you know?
I don't know, I just have to say this. I never tried to.
It's brilliant. It's a brilliant invention. Okay, we'll talk about slide rule another day. But the point is, we didn't have computers, so we did calculation using an old mechanical device called a slide rule. It would be something like taking a computation course today using abacus, using like a Chinese abacus. I mean, it would seem silly because we have all these computers, but just a few decades ago, that's how people were still making calculations. So the curriculum has changed constantly, and now we're ready to move into our second assignment. Okay. We're still on this concept of what is an engineer? Okay, so your program, the advanced program, is supposed to be equal to the BS degree, right, Bachelor of Science in Mechanical Engineering at university level. Okay. We said that engineering includes some design. Right, this is the art or creativity part. Science. You must have a good science background to make your design work. Mathematics. You said there were problems, well, not necessarily problems, but issues. There were concerns with whether or not the government supports certain projects, whether or not business supports certain projects. Is it going to make a profit? Does it serve some human need? The government projects normally are supposed to help the population somehow. You build a road, or a hospital, or an airport. Business projects usually are to make a profit, MP3 plan. But one way or another, you need that other influence. So I'll say politics and business. We talked about this. Okay? We talked a little bit about the interdisciplinarity. And cooperative nature. Maybe not enough about this, but most products today require a lot of expertise, like take an airplane, for instance. An airplane is full of very high-level materials. You need materials engineers. It's got engines that have to be very efficient, combustion engineers, chemical engineers. The structure of the airplane, structural engineers, has to be very strong. Electronics, the plane is full of electronics, electronic engineers. Aerospace engineers for the fluid flow, putting it all together, right? Lots of different people come together. That's the idea of the interdisciplinary, spell right, and cooperative. Okay, so here's your assignment. I want you to perform your own personal analysis, evaluation of the UP, BS, and ME program. Okay? You can find it here. And it's based on so-called credit hours. Credit hours are something like the currency of the degree program, like money. In order to get the BS degree, you need to accumulate a certain number of credit hours. So first of all, figure out how many total credit hours. Then figure out how many of those are in science, how many are in math, how many are in creative courses like design, And last of all, how many are in so-called general education? General education is everything else. It could include literature, it could include politics, it could include history, philosophy, anything like that. Okay? Anybody have a question about what I'd like for you to do? So you're going to have to go online. You're going to have to go to this website. On this website, that's the home page of the department that offers the bachelor's degree in mechanical engineering. That department has other things too, though. It has a bachelor's in aerospace engineering. It has master's degrees. It has a PhD. It has some links to research projects. So it's not the only thing on there, but that's good, because if you can look around at some of those other links too, get to know a little bit more about the department. But the main assignment is find the bachelor's degree program in mechanical engineering. It's on there, right? There's a student manual. There's a guide to students that want to get the bachelor's degree. It explains how many credit hours they need. And it also gives all of the courses for 4 years, semester by semester. It tells you what to take. I want you to look at those courses. The descriptions are there. Look at them and figure out for yourself how many of them are in science, how many are in math, how many are in design, how many are in something else. Okay? And get a good idea. See if you think that the current program fits this. Right? We've talked now for 2 days about the philosophy of engineering and what we're trying to do. We're trying to create a brave new world. We don't have a long history of engineering education. So you be an engineering education designer. Does this education accomplish what we say we want to accomplish? Okay? Don't be afraid to be critical of it if you think there's a problem with it. Does anybody have any questions? Okay, so good. I'll see you Friday. Well, I'll see you tomorrow. I want to see this on Friday. So start on this tonight so you can ask me questions if you have any questions tomorrow. And you, get rid of that Japanese soccer t-shirt. Yeah, you. No, that's okay. I'm teasing because Japan played the rest of the World Cup.